Okay, my name is Anja Feldmann. I'm from the Technical University in Munich, Germany, and what I'm going to talk about today is what are the kind of a nicer way of abstracting and kind of representing and realizing AS-wide routing policies for your BGP routing. So this kind of goes back to some of the things that we've been talking about here today and yesterday, that a lot of people should be doing filtering, and if you leave out one session, then you screw up all of your filtering. And what is a way to actually get around and doing some of these things in a right way? So let's get moving with kind of just briefly reviewing what do I mean with a routing policy here. So in some sense, if you have your AS over here, then really what is a routing policy all about? Well, it is all about what routes should you actually accept here, and you should probably make sure that you don't accept the routes that you shouldn't be accepting, and then you probably want to manipulate them. Then they need to be sent out, then again manipulated them, and then you need to decide which routes you actually want to set out. And all of this, the way that it is done for all of the various different BGP sessions, is what your routing policy is. Now, the problem with the way that routing policies are currently handled, in my view at least, are that they are unfortunately often ill-specified. Because think about it. If you're operating a network, where do you have your documentation? Is it in all of the various different BGP statements that you have out there on your routers, or do you have it actually written down? And I think that that is one of the major problems, that the routing policy is ill-specified, and really the database is the network itself. And then you have some kind of a problem on one of your customer links, you go in, you manipulate it, and suddenly the routing policy changed again. A lot of the things are customer specific. You have to go about, think about which kind of BGP statements to tweak in order to figure out, this is how I do various different aspects of it. Now, the goal of this work here is that we get away from some of the manual configurations here and actually go about and being able to kind of take apart the AS-wide routing policy into various different pieces so that we, on the one hand, raise the abstraction level, but on the other hand, are still able to actually automatically generate all of the different pieces of the configurations for not just one router vendor, but actually multiple router vendors. And this is what I'm going to talk about today. So what do I mean by routing policy? And I have some various different examples that actually contribute to a routing policy. What are they? Well, on the one hand, you need to make sure that you actually honor all of your business relationship, which means that you get the peering right. Then you probably want to make sure that you have the right kind of preferences set, so that the customer routes are preferred over the peering routes, etc. But there's another kind of a trend going on, which is that really BGP policy has gotten quite a bit more complicated. And that is, some of the peering customers, transit customers, actually do want some amount of control about their routing. And actually that's possible. That's what all of this community handling is all about. So that you can actually give some amount of control about the traffic engineering to each one of the customers. We've seen that earlier today when we were talking about the IPv6 multi-homing. And then there are additional services, and that is maybe you want to be able to actually do some black holing in order to get around a DDoS attacked IP address. But of course there are problems to that, because really what you have, if you have new customers that want all of this, you need to kind of say, this is what this customer has, maybe not this one, maybe this one, and this is something that everybody has to have. So what we really have is that the policy doesn't just consist of one statement of BGP sets, but it really is a set of policies that should apply network-wide, like Boehm filtering, Martian filtering, etc. And then you have some maybe value-added services, or maybe services that everybody is supposed to have. So really, the routing policy is a set of policies and services. So let's take an example, and let's think about how some of these services are actually realized. So let's look at black holing. How do you might want to do it? Well, it all comes down to the point that you probably want to have some kind of a trigger in order to say, okay, now I want to black hole all of the traffic for this specific IP address. How do you do it? Well, you use a community as a trigger. Then, on the routers, you actually rewrite the next hop so that all of the traffic is dropped to a def null interface. But the problem is, of course, you don't want to allow everybody to do that, because otherwise you have a nice new DDoS attack here. So you actually want to make sure that you have some amount of authorization here, and you also want to deploy some other safeguard here, which is do a no export. So how is it realized? Well, there are various different steps to it. You want to make sure that on ingress, you actually allow this black hole community only for the specific customers that actually are supposed to be able to use it. You also want to make sure that the routes for which it's being used are only the ones that are actually in the authorized set. Then you need to be able to rewrite the next hop, and you want to make sure that you actually don't advertise this route any further. So on egress, you have to make sure that you do filtering of all of these black hole routes. So what is it? What I mean with an atomic unit of a BGP policy or a service here. So really, what you want to be able to do is probably say, for this specific set of BGP sessions that I actually want to identify in some kind of a network-specific independent way, but let's say, those are the one sessions that have this server selected, or that have our peers, or those that are customers, and I basically want to be able to select them, but I want to be able to do this in some kind of a vendor-independent kind of a way. And then, once I have identified the set, I actually do want to apply some kind of a filtering. What filter do I mean? Well, you may want to say, is this really the community being set here? Or is this part of a specific AS set? Or is it part of a specific prefix here? Now, if you want to apply this filter, that is again vendor specific. You can't apply filters vendor independently. And then you want to do some actions. Let's say rewrite parameters, like what we just had, where we wanted to rewrite the next hop, or add a community to it. And this is again vendor specific. So one of the questions that we were asking ourselves is, how can we split this vendor independent part from the vendor specific pieces down here? And the way that we wanted to slice and dice this whole problem of BGP configuration is to say, let's take the elements that are network specific and put them into a network database here. So we have a network module which contains a description of our various different network elements. And then we wanted to have a policy and service module which basically takes the abstract definitions of the various different individual routing policies and services, and this can be done now in a way that is completely network independent and vendor independent. And then we wanted to, can't of course realize any of this without any specific kind of a vendor treatment, and so we needed to have kind of a library of vendor specific code fragments that can then be combined to actually realize the set of policies to be used for specific sessions. And all of this is actually then accomplished via a configurator which takes these various different databases as inputs and then produces various different pieces of configuration configlets, or actually produces RPSL. Now, you might want to ask, why didn't we just use RPSL? And the main reason for that is that what we are doing here is actually adding another layer of abstractions on top of the kind of capabilities that RPSL has. Because really what we want to be able to do is we want to kind of separate the process of BGP configuration into the various different steps that can be done by different people. Like the network module, that can be maintained by the staff that is actually responsible for selling and configuring the network. You don't need a BGP expert for that. The BGP expert should be able to kind of set up the various different policies and services here, and maybe help with actually putting together the configlet code that is being stored over here. but they should not be involved in actually doing the day-to-day kind of maintenance of the various different sessions. And so this is why we choose this. Let's actually go in and kind of get away from this high-level description into a more concrete description. So let's take a look at the network module one by one. And the idea here is that we actually wanted to capture the current state of the network and also the current service subscriptions. And so the elements that we have over here are router, BGP neighbor, session, and services. Now, why do we have a neighbor and a session here? Well, most of the peering sessions, most of the customers are not realized via a single BGP session, but actually via multiple ones that usually have the same kind of characteristics, and you want to be able to kind of formulate that you want to have the same kind of policy on every single of these sessions. And so that's why with a BGP neighbor, you can set policies for all of them. So how does this look like? Let's say we have a router, which is has a certain name, a loopback IP address, is located in a different city, and has a certain system specification. For example, in this case, a Juno OS with a specific Juno OS version here. Now, why do we need this information about the location? Well, because maybe you want to actually tag any kind of a route that is being originated from this router with the location information that it comes from the region Europe, or more specifically Germany. And so this is where you can get this kind of information from later on. Now, a BGP neighbor is being set up over here, which has a certain neighbor AS. So this is then being used to actually generate the BGP statements from. Then you have a certain neighbor type that can be used to finally figure out how to realize the BGP peering policy. And then you have a set of sessions that is associated with it, in this case only one. And here we have filter, import, and export statements. Now, these filter, import, and export statements are being not realized by the system itself, but here we take advantage of the fact that with the existing databases and RPSL, we have a nice way of manipulating filters. So we actually reuse this, and it also gives us the ability, with access to the databases here, that if your filter changes, you don't have to go about and to change the configuration here, but actually you just, as a customer, can change your element in the database, and then this is being picked up and updated on the routers automatically at some later point. How does the session look like? Well, you have over here your name, which is being referenced above. You have the location on which router it is, you have the remote address, and then you have a set of services over here which may apply to this session over here. Now, you have services that can be specified on the neighbor, or you can have it on the session. Now, if something is specified on the neighbor, then it is automatically inherited by all of the sessions. Alternatively, it can be overwritten. And you have the ability to kind of say, okay, let's say we want to actually have a specific filter over here, and for those routes for which this filter applies, we want to set a match value of 2000, for a different filter, a different match value, and a different kind of a default value if none of these filters over here actually applies. Now, given that we know how a network is being specified, we can go about and actually worry about our policy. So what did I say about the task here? Well, what we really want to have is some kind of an abstraction so that we can express a policy. What do we do when we say a policy? What you usually mean with a policy is actually that you want to select a session set, and then you want to apply certain BGP operations on them. And so this is exactly the kind of elements that we have support for in this kind of a database description that we are proposing here. So we have two top-level elements, policy and services, and here's an example of how such a service could actually look like. And the service that we have here is Blackhole. So what did we say when we were kind of looking at the service? We said that we want to have an authorization here. And so one of the things is you have a parameter here, which is a Blackhole set, for which you can This is the kind of filter that restricts you onto the kind of prefixes for which you can actually apply this. So this could, for example, entail all of the more specifics of the route set that that customer may actually have or be defined in some other kind of a way. Then, for all of the ingress direction over here, you want to be able to kind of say, if this customer or this peer has actually subscribed to the service black hole, that's the condition that we have over here, then you actually want to be able to perform a check for the black hole community, and if so, then you actually want to realize the black hole service. And for that, we are using two different fragments over here that actually realize the necessary BGP filtering and the necessary BGP manipulations here. If it's not the case that the service over here is being sent, then the thing that you have to do is actually filter out any route that might have this black hole community set. And this is why we have this fragment over here, which says ingress black hole community deny, which means that this route will not be accepted. Now, there's one more thing to point out, and that is this service black hole over here was actually kind of conditioned on the fact that the service black hole was actually booked by somebody. Of course, you have other kind of policies that you want to definitely realize. And this is the distinction that we are making up here when we are talking about enforced policy, which could be peering or Martian filter or Boehm filter, which will be realized automatically for all sessions independent of what the subscription model would be. And then you have the available services, which can be booked and specified on a per session or per neighbor basis. Now, all of this, of course, depends on the fact that you have a way to actually realize the various different BGP operations. And that is the task of the backend model, which actually encapsulates the vendor-specific elements, and such provides kind of just a list of different named fragments which can be used to actually realize the various different services and policies. And so how do we do this? Well, we have basically another kind of a database which contains these, and of course in order to then customize any of the various different statements, you have to be able to cross-reference both into the policy module as well as into the network module in order to figure out what are the specific values to be used. And since this is fairly abstract, let's look at an example again. And this example here, what does it do? It's for Cisco iOS, and it actually filters out the black hole community here. So what do? We have a part over here which actually sets the neighbor statement over here based on the remote IP address and the route map in. Now the route map itself, of course, has to have certain elements which are being highlighted here. So you have to put it in some kind of a relationship, then you have to kind of filter on the black hole set, match the community, set the next help IP address over here, and then set the community no export. Now, there are various iOS-specific elements over here. One is a route map priority, which is being used to actually then combine the route maps into the from the various different fragments into the right kind of priority order. So in terms of prioritization, the thing to keep in mind here is that this system doesn't take away the need to think about in what order do you actually apply the various different BGP statements, but it helps you to be able to do this once and not have to redo it for every single peer, for every single session that you have to set up. Now, to continue means that this is not a final decision, so this wouldn't be a deny or final accept, but that maybe you want to do some additional manipulations here. You, of course, also may have to have some kind of filter here. And again, we are taking advantage of the fact that these filters can actually be parameterized. So, for example, you have the community names that are being actually constructed via an external database, and so you can even change those values if you wanted to. Now, of course, what I've shown you over here was only the part for the Cisco IOS, but for Juno OS we have a similar version as well as for RPSL, and it's easily possible to expand this for other router vendors. Now, once you have all of these various different databases, you can actually go ahead and combine them and generate the configlets. And so what is the task of this configurator? It actually goes ahead, takes all of these three databases, checks for consistency, combines the various different atomic units into the appropriate routing policy for every single BGP session, and then actually generates the configlet parts that can now be uploaded to the various different routers to actually configure it. And of course, if you combine various different BGP session pieces, you need to kind of make sure that actually a good overall routing policy is a result. And we can either use the Cisco continue feature here, or we can actually fold it into a single route map. Or with Juniper, we take advantage of the next policy feature with RPSL, the refine statements for this. And this is actually not just vaporware, this is actually a real implemented system and is being used by Deutsche Telekom at the moment. How does this look like? Well, this is the kind of output that can be generated. So you have the BGP statement for this neighbor over here with the various different parts here. You have the out route map, the in route map, you have the various different filters, the prefix list, etc. And if you don't want to if you aren't able to use the continue feature for Cisco IOS, well, then you actually have to combine the various different pieces so that, what do we have here? Well, on the first hand, we have a Martians filter. The next one over here checks whether the routes, whether you actually have the authorization for the black hole or not. If not, then it may actually be rejected. And only if you have it, then you can actually set the community and rewrite the next hop, etc., etc. And one has to keep in mind that this is only a small subset and an example over here. And the same kind of output can be generated not just for Cisco, but for Juno OS and RPSL itself too. So what do I think the benefits of a system like this are? I think the benefits are that we can actually now have an explicit specification of the routing policy, and it isn't just kind of in the router configlets anymore, but it really is independent of the network itself. Also, what you gain is a separation of your routing policy into the various different pieces, so that it's clear what are the additional services that you offer to enable customers or peers or transit customers more control over their own traffic. It also allows you to introduce new services fairly quickly, because you can actually do this in a kind of a two-stage manner. First, you most of all have to actually set up some preparational meeting, because, for example, if you wanted to allow prepending to specific ASs, then you first need to before you can sell the service, you have to prepare for all outgoing sessions that the service is going to be supported. And so this is the first step. And once you have enabled it for all the outgoing sessions, then you can actually enable it for some incoming ones. And also, you can easily take advantage of new router features, because the only pieces that you need to change is the backend module and the necessary fragments over there. You also respect the knowledge domains, because you really, the backbone person can now focus on the various different policy. They don't have to worry about the specifics of the network anymore. So let's get away from actually hacking BGP configs. And of course, you can automatically generate the appropriate router configlets for this. And I'm curious for feedback from any of the people here, and be more than happy to talk with them about what they think about it, what could be the kind of way of moving forward with it, what the various different policies should be, and to exchange experience. Questions?
Thank you very much. I have a question. You're going to encourage me to stop using VI to edit my router configs and or sitting at the console?
Yes.
out of my cold, dead fingers. Or, I'm sorry, Ruediger?
Well, there are operators that actually manipulate the XML that was shown as the definition, I like to say, of services or network connections using VI or whatever editor or graphic GUI thing they want to do.
At what's the trade-off in the number of routers or number of configurations that you need to maintain? I mean, if I've got 2 routers, is this an efficient use of my time? If I've got 2,000 routers, where's the break point?
Well, with 2 routers, I somewhat suspect that you probably will have so simple requirements that it doesn't justify the learning curve. On the other hand, if you are implementing something like 50 policy and signaling elements in the service that you are building across 100 routers, and you want to have the ability to add another 12 over the next quarter year, well, I think it's worthwhile to consider this.
Thank you.
So basically, it depends on the complexity of your network. You're right. For 2 routers, it's probably not it. But if you want to scale the 2 routers to 100 routers, you probably want to think about some kind of an automated system to generate the configlets for those.
Okay. I'm going to ask for a straw poll. How many people in this room configure routers themselves, not having somebody on their staff? Keep your hands up. How many people, or for the people that would use a tool like this, keep your hands up. If you're wouldn't use a tool like this, put your hands down. Do you guys, with your hands up, have tools like this now? Big hum, yes. How many people are going to go download this code immediately? Okay. Get those guys right there, right? All right, again, thank you very much. It's break time.